Okay, so hopefully this time is okay. So I need to send you guys this link. I have to send this link to you guys. Okay, wait. Right, so now I can see them. Okay, good. Is it again? Tak kot. Okay dah kot. Ting ting. Can you guys write down if you can hear me clearly or not? Can you guys hear me clearly? Okay ke? This is my first time using the OBS, so I'm not sure whether is it okay or not. Okay, tak okay. Can you guys write down so that I know? Okay, yes, okay. So since you guys can hear me clearly, so that is okay. Kalau tak clear, kena bagi tahu tau, so that saya boleh tukar kepada mic. So kena buat setup baru lah pula. Oh, pening. Oh, hi. Right, so now this is chapter 9, differentiation. So obviously we have 5 lectures sorry, for differentiation. So this is the first one. Okay, next. So we do have 5 subtopic. So we are going to start with the derivative of a function, which is today, and then we will proceed with some basic rule for differentiation. So that means I will do 9.1 as well as 9.2, and then we will proceed with 9.3, 9.4 as well as 9.5. So differentiation of exponential, logarithmic and trigonometric function. I think this is quite new. I think for some of you might be quite new. Oh ya ke? 240 je. Later lah. Later I change. Boleh Fat? Later I change to high quality. Rasa sebab internet dia, so OBS tak bagi tinggi sangat kot. And then implicit differentiation, parametric differentiation. So today we are going to focus on 9.1 and 9.2. Next. Okay, so the learning outcome for today is that the first one, you should be able to determine the derivative of a function using the first principle. So when we are talking about using the first principle of differentiation, that means we are going to use this formula to calculate the gradient or the derivative of the function. So f prime of x is equal to the limit as h approaches 0 for fx plus h minus with fx over h. So that is the first one. And then the second formula is to determine the differentiability of a function at a certain point. Okay, so for the first one, this is in general. So very general. In general, we are going to use this formula. But if we want to determine the differentiability at a specific point, we are going to use another formula. So we are going to modify the general formula a little bit so that we can determine the differentiability at a certain point. So I'll give you the formula later on. Okay, and then we should learn how to apply the rule of differentiation. So for today, it's just a simple rule, which is the basic rule, which involve the power rule and the constant as well as the power rule. And then we are going to learn about the sum rule, what will happen if we have an addition or subtraction between those two functions. Okay, next. Derivative of a function. Oh, tapi rasa macam tak berapa nak clear dah pula. Nampak tu, tapi tak apalah. Okay, derivative of a function. The process of finding the derivative dy over dx of a function y equal to fx is called differentiation. Okay, so sometimes we are going to use dy over dx. Those are differentiation as well. F prime of x, that is also differentiation. And then y prime, that is also differentiation. So sometimes we use dy over dx, sometimes we use f prime, sometimes we use y prime. Okay, so if y is equal to fx, then f prime of x. Okay, so this is the first principle of differentiation, which is this is the limit for h approaches 0 for fx plus h minus with fx over h. Okay, so let's see the step. How to do the first principle of differentiation. So I'll give you a few steps. The first step is that you must write down the formula, determine what is your fx, and then determine what is your fx plus h. So you have to determine two things, fx and then fx plus h. Okay, and then you should be able to expand them or multiply them with the conjugate, because basically when we are finding out dy over dx or f prime of x, we are going to get 0 over 0 somehow. So that's the reason why we have to either expand or multiply with the conjugate, because we get 0 over 0. Okay, expand or multiply with the conjugate, make sure to factorize and terminate the h, because we don't want the function to have h when we substitute the limit. Okay, so write down the answer without the term h. After we substitute the limit, we no longer want anything with h. Okay, so let us see the example then. Okay, so by using the first principle, find out what is f prime of x for fx equal to ax square plus bx plus with c. Okay, so firstly, determine what is your fx together with your fx plus h. Okay, so fx, you simply copy down everything. So fx is ax square plus bx plus with c. Fx plus h, so you need to replace all your x with x plus h. So you will have ax plus h square, bx plus h, and then plus with c. So those are fx plus h. And then we are going to substitute into the formula, where we have f prime of x equal to the limit as h approaches 0 for fx plus h minus with fx over h. So you will now replace what is fx plus h and then fx. Kesiannya tak apa nak nampak sangat tu. Tak apalah. Okay, so now replace the fx plus h and fx. So you will have ax plus h square plus bx plus h plus with c minus with ax square plus bx plus with c. Okay, so what will happen? Okay, so I'll give you some tips and some trick. Okay, so if you substitute fx plus h inside here, once you expand them, you should be able to cancel out the term in fx. We definitely going to cancel out all the term in fx. So you just need to expand or you simplify your fx plus h. Okay, so now I have x plus h square. So I'm going to expand x plus h square. So they will become x square plus 2xh plus h square, and then b multiply with x plus h. I'm going to expand them as well, and then I will cancel out with those ax square, bx, and c. Okay, so let's see what happened after I expand them. Okay, so I will have ax square plus 2xh plus h square plus bx plus h plus c minus ax square minus bx minus c. Okay, so now as you can see over here, ax square, those can be cancelled out with ax square. So do them very carefully. You should be able to cancel out the term in your fx. Okay, so bx can be cancelled out with negative bx. C will be cancelled out with negative c. So we are left with 2axh plus ah plus bh over h. Okay, so up until here, if you try to substitute with h equal to 0, what will happen if we try to substitute with h equal to 0? Okay, so you are going to get 0 over 0. So if we try to substitute with h equal to 0, we are going to get 0 over 0. So that is why we have the third step where we have to factorize and cancel out the term that will give us 0 over 0. So this is similar to limit because this is limit, right? So if we have 0 over 0, we should factorize and cancel out the term that will give us 0 over 0. Okay, so I factorize the h. So I will have h 2ax plus ah plus b over h. So now we can easily cancel out h and h. So we have the limit as h approaches 0 for 2ax plus ah plus with b. So now you can easily substitute with h equal to 0 and they will give you 2ax plus b. Okay. Nanti next time saya edit dia punya setting lah. Sekarang kalau saya edit setting dia, nanti saya kena restart balik OBS ni. So boleh tak saya go on je dulu? Memanglah dia sakit mata sikit sebab dia 240 je kan. Dia kabur. Kabur tak tahulah nak cakap kabur macam mana. Boleh? Okey ke? Sial ni guys. 240 je. Penat aku edit slide ni. Kemain cantik lagi. Lalas kabur je. Aku 2 pagi aku tidur. Sabar je lah. So untuk siapa yang datang lambat, it's not because of your phone. It's because of my setting. Sebab saya suruh dia optimize sendiri. So dia optimize untuk 240. So sorry lah kalau nampak macam low quality sikit. I'll send you the PowerPoint later so that you can easily see all those number. Okay? Boleh ni? Can we proceed to the next question? Saya tak fokus pun. Dia punya kualiti dia berapa. Yang saya fokus, saya boleh tulis tu je. Okay then. Right, next. Okay, so now by using the first principle, we are going to find out the derivative for fx equal to square root of x. Okay, so the first step, you must be very clear what is your fx and then fx plus h. So we have to determine that one first. So fx is square root of x. So fx plus h, that means we just replace the x over here with x plus h. So they will become square root of x plus h. And then you're going to substitute into the formula where we have f prime of x is equal to the limit as h approaches 0 for fx plus h minus with fx over h. Okay, so we are going to replace this with the square root of x plus h, and then we are going to replace the fx with square root of x. So just replace them. Okay, so now you are going to get the limit as h approaches 0 for the square root of x plus h minus square root of x over h. Okay, so now, if let's say you do try to substitute with h equal to 0 over here, what will happen is that you are going to get square root of x minus square root of x over 0, which is 0 over 0. So you do know that this is undefined, so we cannot define 0 over 0. Therefore, we have to multiply with the conjugate. Okay, so now we have our set in our numerator, so make sure to multiply with the conjugate. So this is square root of x plus h minus with square root of x. So in order to multiply with the conjugate, I will change the sign to become positive. Okay, so change the sign. So I will multiply with the square root of x plus h plus square root of x over the square root of x plus h plus square root of x. Okay, so similar thing to limit. If you have the conjugate, something, a function, multiply with its own conjugate, then you expand. Otherwise, you just leave them inside a bracket. Okay, so now for the numerator, I see that they are actually the conjugate of each other. So I'm going to expand them. But for my denominator, they are not the conjugate of each other. So I will leave them in the bracket. Okay, so what happened after I expand them? So I will get the limit as h approaches 0 for x plus h minus with x over h, and then multiply with the square root of x plus h plus with square root of x. Okay, so I just expand them. Okay, expand them. So you are going to get the limit of h approaches 0, x plus h minus x over h, square root of x plus h plus square root of x. And then what happened is that you're going to simplify them. So x minus x, those will cancel out each other. So we are left with h. So we got the limit as h approaches 0 for h over h, multiply with the square root of x plus h plus square root of x. Again, if you do try to substitute with h equal to 0, you are going to come out with the same conclusion, which is 0 over 0. Why is that? That is because we haven't cancelled out the term that will give us 0 over 0. So now you should be able to cancel out the h and the h. So we are going to get the limit as h approaches 0 for 1 over square root of x plus h plus square root of x. So make sure, try to substitute. If you still get 0 over 0, then most likely you have to factorize them first, because we need to cancel out the term that will give us 0 over 0. So we don't have anything with 0 over 0. Okay, so now substitute with h equal to 0. So you are going to get 1 over square root of x plus with square root of x. So square root of x plus square root of x, that is just like a plus a, which is exactly equal to 2a. Okay, so we are going to get 1 over 2 square root of x, because we have set x plus set x. So they will become 2 square root of x. Okay, so those are the general formula when you want to differentiate. Of course, this is quite tedious, right? If you have a very big function and more complicated function, if the function is very easy, we can easily calculate our derivative using the formula. But since if we have a more complex function or a more complicated function, it will be very tedious to do all those things. That's the reason why we have all those basic rule of differentiation, and then how to differentiate the exponent, trigonometric function, and etc. So that is why we have 9.2. This is 9.1, right? 9.2, the basic rule of differentiation, because of course lah, takkan nak buat benda ni panjang kan. This is macam basic lah, dari mana datang. Lagi macam, oh, differentiation, tak tahu dari mana datang. So this is how they come out with the formula to differentiate things. Okay, so now let us discuss how to find the differentiability at a certain point. So that means I want to test the differentiability at a certain point. Okay, so the formula is, if you have to find f prime of a, so that means you want to find a derivative at a specific point, which is f prime of a, then you're gonna do the limit for x approaches a for fx minus with fa over x minus a. So now this is different, okay, from the previous one. In general, we have h approaches 0, but this one is x approaches a, and then fx minus fa over x minus a. Okay, so of course, in order to let this one to become true, you must make sure that the limit as x approaches a from the right hand side, and then the limit for x approaches a from the left hand side must be equal to the same value. So both of them must be equal first before we can say that it is differentiable. Okay, so if a function is differentiable, then automatically the function is continuous. But a function may be continuous but not differentiable. It doesn't work the other way. So if it is differentiable, automatically it must be continuous. If the function is continuous, it might not be differentiable. Okay, so for example, this is something called a sharp corner. So this is a sharp corner. So let's say that is the value of a. So if you calculate the f prime on the left hand side and the f prime on the right hand side, you are going to end up with two different values. So the limit does not exist at this point over here. So this is for a sharp corner. And then this is for something called a vertical tangent line. Where the gradient is infinity. Okay, so if you have a different limit on the left hand side and right hand side, which is the first case over here, then we can say that it is not differentiable at x equal to a. Okay, next. Right, so now by using the first principle, find f prime of a for fx equal to x squared plus 3, where a is equal to 3. So we have a specific point over here. So you need to use the formula with x approaching a. So because we have a specific value of a, we need to use the limit for x approaching a. Okay, so now let us check what is the value for fx as well as fa. Okay, so f of x is x squared plus with 3, fa. So fa is actually f3. So f3 is equal to, you just substitute x with 3. So we are going to get 3 squared plus with 3, which is exactly equal to 12. And then we're going to substitute into the formula. F prime of a is equal to the limit as x approaches a for fx minus fa over x minus a. Okay, so substitute the function fx, substitute fa, substitute the a in. So we are going to get the limit for x approaches 3, x squared plus 3 minus with 12 over x minus 3. Okay, so simplify the constant because I have positive 3 and negative 12. So we can actually simplify them to become negative 9. So they will become the limit as x approaches 3 for x squared minus 9 over x minus 3. Okay, so now you can substitute x equal to 3. You will end up with 3 squared minus 9, which is equal to 0. And then 3 minus 3, which will also give you 0. So if we have 0 over 0, we get stuck. There are two methods to solve this. Either you factorize them or you multiply with the conjugate. But we don't see anything with a set, so nothing to do with the conjugate. Therefore, you have to factorize. So who to be factorized? Of course, the higher power need to be factorized. You are not going to factorize the linear, right? So we are going to factorize the quadratic up there. So x squared minus 9, when we factorize them, we are going to get x plus 3 together with x minus 3. So when we factorize, we are going to get the limit for x approaches 3, x plus 3, x minus 3 over x minus 3. So now we need to cancel out the term that will give us 0 over 0. Otherwise, we're still going to get 0 over 0. So you need to cancel out x minus 3 and x minus 3. So this is the limit for x approaches 3 for x plus 3. So now you can easily substitute x with 3. So we got 3 plus 3, which is exactly equal to 6. Okay, so this is the value for your gradient or your dy over dx, your f prime of x at x equal to 3 or at a equal to 3. Sakit mata pula dah tengok kualiti dia rendah sangat. Okay, next. Right, so now fx is equal to 2x for x less than 0, x square for x greater than or equal to 0. So now the question is, if f differentiable at x equal to 0, so we want to know whether f is differentiable at x equal to 0 or not. So that means you have to test from both left hand side as well as right hand side, because we have a piecewise function, so you have to test from both left hand side and right hand side. Okay, so now make sure to draw the number line first so that we get the correct function. So we have 0 over here. So on the left hand side of 0, the function is 2x. On the right hand side of 0, the function is x squared. Okay, so on the left side, I will use 2x. On the right hand side, I will use x squared. Okay, so now we have to check whether f is differentiable or not. So I need to make sure I check from both left hand side and right hand side before I make a conclusion for them. Okay, so f prime of 0 is equal to the limit for x approaches 0. So this is for the left hand side. Fx minus with f0 over x minus 0. Okay, so what happened now? Fx, okay, so make sure you choose 2x. Okay, so this is the limit as x approaches 0 from the left hand side, 2x minus with 0. So when we substitute x with 0, we are going to get 0. And then you divide them with x minus 0, which is simply x. Simplify them a little bit, so we are going to get the limit for x approaching 0 from the left hand side for 2, because we have 2x over x. So when we simplify them, they will become 2. So the limit for a constant is simply equal to that constant. So this limit is simply equal to 2. Okay, so now I have to test from the right hand side and check whether do we have the same value or not. Okay, so f prime of 0, so this time is the limit for x approaches 0 from the right hand side. So not from the left, but from the right hand side. So fx minus f0 over x minus 0. Okay, so the function. Okay, so the function is x squared on the right hand side. So this is 0, on the right hand side is x squared. So x squared minus with 0. So you just substitute x with 0, you are going to get 0. So x squared minus 0 over x. Okay, so what we are going to get is x squared over x. So you can easily simplify them to become x. So this is the limit for x approaches 0 from the right hand side for x. And then you just substitute x with 0. So we are going to get the limit, which is equal to 0. Okay, so now this is 2, this is 0. Are they equal? So of course, you can easily see that they are not equal. If you don't know they are equal or not, that will be terrible. Kalau tak nampak kenapa dia tak equal tu, masalah sikit lah. Okay, so they are not equal. Therefore, we can say that f is not differentiable at x equal to 0. So perhaps this is either a sharp corner or perhaps we have a vertical tangent line. So that's the reason why f is not differentiable at x equal to 0. Only at that point, f is not differentiable. Sama je. Nak Okay, next. Right, so now determine whether the function f(x) equal to the modulus of x is differentiable at x equal to 0. So you might want to use the function straight away, but no. If we have an absolute value, we have to define the function first. So that means we have to change from absolute value to become a piecewise function. So make sure keep that in mind. If you have an absolute value, you have to open them using the basic definition to separate them into a piecewise function. Okay, so now we have the modulus of x. So there will be two things: x for x greater than or equal to 0, negative x for x less than 0. So I change from the modulus, I use the basic definition of the absolute value. So I change it to a piecewise function. So x and negative x. Okay, so now make sure to draw your number line so that we have the correct function on the left hand side and right hand side of 0. Okay, so on the left hand side of 0, that is for x less than 0, therefore the function is negative x. On the right hand side of 0, the function is for x greater than or equal to 0, therefore the function that we are going to use is x. So the first one is negative x, the second one is x. Okay, so what happened next? Okay, next, we have to find out what is your f prime of 0 for both left hand side and right hand side. Okay, so now f prime of 0, that is the limit for x approaches 0 from the left hand side first. So I start with the left hand side. So the function is fx minus f0 over x minus 0. So the function that we are going to use is the function on the left hand side of 0, which is negative x, because that is on the left hand side of 0. Okay, so I will replace the fx over here with negative x, and then I will replace the x with 0 in order to get f of 0. And then we just need to divide them with x minus 0. Okay, so this is the limit for x approaches 0 on the left hand side of negative x, negative 0 over x. So negative x over x, you can actually simplify them. So they will become negative 1. So we got a limit for x approaches 0 from the left hand side. So how do we get this negative 1 over here? Is because we have negative x over x. So negative x over x, they will become negative 1. So limit for a constant, they will become the constant itself. So this is simply equal to negative 1. So you can do the same to calculate the limit for x approaching 0 from the right hand side. So we're going to calculate one more thing. Okay, so the limit for x approaches 0 on the right hand side for fx minus f0 over x minus 0. Okay, so this will become the limit for x approaches 0 from the right hand side. Okay, the function on the right hand side of 0, we are going to use x. So x minus 0 over x. So you can actually simplify the x with x. So we are going to get 1. So this is the limit for x approaching 0 from the right hand side of 1. So how do we get 1? X over x. So the previous one, when you simplify x over x, we are going to get 1. So the limit for the constant itself is simply equal to the constant, which is 1. So negative 1 and 1, are they equal? Definitely not. So they are not equal. Therefore, we can say that f is not differentiable at x equal to 0. So definitely not differentiable at x equal to 0 because they are not equal. Okay, next. Example 4. Show that fx is continuous but not differentiable at x equal to 1. So now we want to see what's the difference, because we recently learned about limit and continuity. So you might get confused with limit and continuity as well as the first principle of differentiation. So for this example, we're going to see what is the difference between how to check for continuity and how to determine whether they are differentiable or not. Okay, so check for continuity. How many conditions do they need to be satisfied? There are 3 conditions for continuity that you have to check. The first one is that you have to make sure FA is defined. What does it mean by FA is defined? That is mean when you substitute the value of A, you should get a certain value. So when you substitute the value of A into the function, you will get some value. Mesti ada nilai lah. And then the second one, the limit for x approaching A for fx, they must exist. So in order the limit for x approaching A for fx exists, it simply means that if you find or if you calculate the limit for x approaching A from the left hand side and right hand side, they need to be equal so that the limit for x approaching A exists. And then the third one is the conclusion, where you have to make sure that the value for FA need to be equal to the limit for x approaching A for fx. So they need to be equal first before we can say they are continuous. But they already told us that the function need to be continuous, so you must make sure that for your first condition and second condition, you do have the same value. Otherwise, calculate again, because this is a sure question, so you must have the same value. Okay, so now FA is defined. Okay, so draw your number line first. So on the left hand side of 1, we are going to use x squared plus 3. On the right hand side of 1, we are going to use x plus 3. So those are just for us to know which function we are going to use. Okay, so FA is defined. The first one, f of 1, what is the value? So from your function, check where is the equal sign. So the equal sign is for x less than or equal to 1. So you have equal to 1 over here. So that means you're going to substitute x equal to 1 for this function. So substitute x equal to 1. So we are going to get 1 square plus with 3, which is exactly equal to 4. So that is the first condition. So we do check that we do have some value when we substitute x equal to 1. So we define that the value for f1 is actually equal to 4. Okay, the second one, we have to check the limit from the left hand side of 1 and the right hand side of 1 and make sure we have the same value. Okay, so what is the limit for x approaching 1 on the left hand side? So on the left hand side, we are going to use x squared plus 3 because that is on my left hand side of 1. So the limit for x approaching 1 on the left for x squared plus 1. So substitute x with 1, we are going to get 4. Do the same thing to calculate the limit for x approaching 1 on the right hand side, but this time the function must be x plus 3. So just now we have x squared plus 3 because that is 1 on the left. So this is 1 on the right. The function is x plus 3. So substitute x with 1, we are still going to get 4. So you can make a conclusion for this one where the left hand side limit, so the limit for x approaching 1 on the left hand side for fx does equal to the limit for x approaching 1 on the right hand side. Therefore, we will say that the limit for x approaching 1 does exist and they must be equal to 4. If you say that they are equal to a certain value, so that means the limit exists. Okay, so now the third one, which is our conclusion. So you have to check, does 4 equal to 4? Of course, they are equal. So for the third one, we can say that f1 is equal to the limit for x approaching 1 for fx. Therefore, f is continuous at x equal to 1. So we have already checked all those 3 conditions. So now we are sure that f is continuous at x equal to 1. But this one is for continuity. Now we have to prove that they are not differentiable at x equal to 1. Don't worry if you think that you cannot really see all those number. I'll send you the PowerPoint later. Today lah. Today I'll send you the PowerPoint today. Okay, next. Right, so we have to check the differentiability. Okay, so for differentiability, we are talking about differentiability at a specific point, which is in this case x equal to 1. Okay, so again, we are using the same function on the left hand side and right hand side, but this time we are going to test f prime of 1. Okay, so f prime of 1, this is the limit for x approaching 1 on the left hand side for fx minus f1 over x minus 1. So this is for differentiability. This formula is for differentiability. F prime of a equal to the limit for x approaching a, fx minus fa over x minus a. Okay, so on the left hand side of 1, the function is x squared plus 3. So I will replace this fx with x squared plus 3. So we got x squared plus 3 over here minus with, you just substitute x with 1. So we are going to get 4. So the limit for x approaching 1 on the left hand side for x squared plus 3 minus 4. Simplify them. So we got 3 minus 4. So this one will become x squared minus 1. So this is the limit for x approaching 1 for x squared minus 1 over x minus 1. So we are going to get x squared minus 1 over x minus 1. Okay, so this one I jumped a few steps actually, but you can actually see if you try to substitute x with 1, you are going to get 0 over 0. So that's the reason why I simply factorize them. Okay, so now if you factorize x squared minus 1, you are going to get x plus 1 together with x minus 1. So cancel out the term that will give you 0 over 0. So we have the limit for x approaching 1 for x plus 1. Substitute x with 1, you are going to get 2. So f prime of 1 on the left hand side, the limit is equal to 2. Okay, next. You have to calculate f prime of 1 on the right hand side. Okay, so this is the limit for x approaching 1 on the right hand side, fx minus f1 over x minus 1. So of course the function you need to use the correct function. So on the right hand side of 1, the function is x plus 3. So make sure to use x plus 3 over here. So we got x plus 3 as the function and then minus with 4. So you just substitute x with 1. We are going to get 4, so minus 4. So x plus 3 minus 4, simplify them, they will become x minus 1. So we are going to get something like x minus 1 over x minus 1, which can be simplified to become 1. So this is simply the limit for x approaching 1 on the right hand side for x minus 1 over x minus 1. So this is the limit for x approaching 1 on the right hand side of 1. Since this is simply some constant, so we just get the constant itself, which is 1. So you might want to ask yourself now, do we get the same value from the left hand side and right hand side? So one of them you get 1, one of them you get 2. So 2, 1. Are they equal? Of course, not equal. Since they are not equal, we are going to say f is not differentiable at x equal to 1. At this specific point, f is not differentiable. Okay, so those are how we are going to do the first principle of differentiation. So we learn two formula. The first one is the general formula for h approaching 0. And then another one is the formula for the limit of x approaching a. So we got two formula. Make sure you are able to differentiate between these two formula. Okay, next. Okay, so now these are the rule of differentiation. So we do have some basic rule. We have the sum rule. So this is what we are going to cover today, the basic rule as well as the sum rule. And then for the next class, which is next week, we are going to learn about the product rule, the quotient rule, as well as the chain rule. Okay, the basic rule. If you have some constant, you differentiate the constant, you are going to get 0. So if you are not satisfied with how they get 0 easily, you can actually prove them by using the first principle of differentiation. So you can actually do that. So kalau rasa macam banyak masa tu, boleh lah untuk prove kan. Bila kita differentiate constant, we are going to get 0. So you can actually prove them later on. Okay, so if we have x to the power of n, so this is simply a power rule. So x to the power of n, what will happen when we want to find the derivative for them is that we are going to bring down the power. So bring down the power, you are going to write down the n and then make sure to deduct 1 to the power. So they will become n x n minus 1. So take down the power and then make sure to deduct 1 to the power. And then if let's say you have some constant over here, kx to the power of n, what will happen is that you just let the constant be over there. It doesn't matter. So it's like factorizing the constant out. And then we just need to differentiate x to the power of n and then multiply back with the k. So if you have kx to the power of n, they will become knx to the power of n minus 1. So this one actually comes from the derivative of x to the power of n. Okay, so those are the basic things. So you must know this, remember this, understand this by heart. Mesti kena faham lah basic rule. And then you have a sum rule. What does the sum rule mean? If you have an addition, then you can simply differentiate each of them and then add them together. If you have subtraction, then you can differentiate them and then subtract them. So maksudnya kita boleh direct je lah. Differentiate depan, tambah, differentiate belakang. Differentiate depan, tolak, differentiate belakang. So those are the sum rule. I'm sure you have already learned this in your high school level. Okay, so example 5. We can go very fast for this example. All of them are constant, right? So fx is equal to 8. Therefore, f prime of x is equal to 0. They are just a constant. So we are going to get 0 for the derivative. The second one, that is also a constant, 0.73, which is some constant. Again, the derivative for them, which is f prime of x, should be equal to 0. The third one, it might look a little bit complicated, square root of 3, but as you can see, we don't have anything with x. Therefore, this is definitely a constant. We don't see anything with x. This is a constant. Therefore, if you want to find the derivative for them, they are simply 0. If let's say I give you a more complicated fx equal to ln of 3. Ln of 3, do you see anything with x? No. So this one, if you take the derivative for them, they are also 0. What if we have e to the power of 3 pi? Saya create je tau. Ni saya buat je suka hati saya je tau. Saya buat soalan ni. So exponent or Euler number e to the power of 3 pi. So everything is just a constant. E is actually a constant which is called a Euler number. So that means everything is a constant. Therefore, if you take the derivative for them, f prime of x, they should be equal to 0. They are definitely 0 because everything is just a constant. Differentiate a constant, you are going to get 0. And then the second one, we have the power rule where if we have x to the power of n, the derivative is n x to the power of n minus 1. Okay, so what happened if we have to differentiate x to the power of 4? So check the power first, x to the power of 4. So the power is 4. Bring down the power, take the power down. So we're going to write down the 4 in front and then we have to deduct 1 to the power. So they will become 4x to the power of 3. So bring down the power, minus 1 to the power. So they will become 4x cubed. Okay, so similar thing will happen to b. B is differentiate x to the power of 3 over 2. Check what is the power for the x. So the power for the x is 3 over 2. So we are going to bring 3 over 2 down. So they will stay beside the x. So dia akan duduk kat depan tu lah, tepi x tu. And then make sure to deduct 1 to the power. So 3 over 2 minus with 1. So they will become 1 over 2. So we are going to get 3 over 2 x to the power of 1 over 2. Or you can actually change them to become 3 over 2 square root of x. That also work. But just make sure don't write down square root of x below. So this is wrong. Yang ni okey lagi. Okay, C. We got d over dx of 1 over x square. So now you might want to ask yourself, what is the power for the x? Because I need to have x to the power of something. So now this is 1 over x square. So I can actually bring them up to become a negative index. So this is the reason why we learn them in chapter 1. We learn about indices, the rules of indices. Okay, so 1 over x square is simply x to the power of negative 2. So now I can see clearly what is my power. So x to the power of what? So the power is negative 2. So we are going to bring down the power in front. So negative 2, you bring them in front. And then you are going to deduct 1 to the power. So negative 2, negative 1, they will become negative 3. So they will become negative 2 x to the power of negative 3. So you can leave them like this, or you can also write down negative 2 over x to the power of 3. That is also okay. Right, and then D. D, we have to differentiate square root of x. But now, if you want to use the formula, you have to write them down in the form of x to the power of something. But we have square root of x. So you change it to power. So square root of x is actually x to the power of half. So we change it to become x to the power of half, so that we can easily see what is the power over here. So the power is half. So you're going to bring the power in front. So bring the half in front, and then you deduct 1 to the power. So half minus 1, what is that? That is negative half. So we are going to get half x to the power of negative half. Okay, so this one will become 1 over 2 square root of x. So you can also write them down in this form. This one or this one. Either one will do. Okay, so now I'm sure you can do the same thing for example 7 as well. So example 7, I leave that to you guys, so you guys can do this on your own. I'll give you the answer later. But if you have some problem, you can come to me. We are going to do them together. The same thing with example 8, so you guys can do this on your own as well. So if you have some problem, then we are going to discuss next week. Example 7 and example 8, that one will be your work. Okay, so now done with this. So we will proceed with the tutorial. So I'll give you the link for the Google Meet later. So sorry for being so late, lambat sikit. Dia nak set up tu lambat sikit. And sorry sebab video quality tu rendah. Payah sikit lah. Okay, so stop. Bye-bye.